Welcome back, everyone. Time for more math. Exciting, fun, wonderful. 1.5 is inverse functions. So what inverse functions are? They're functions that cancel each other out, or they undo each other. So, for example, let's say we had a very simple function. Let's think of it like a machine again. And what this machine does, let's call it f. It's our function f, machine f. And what this machine does is it takes the input and it adds 2. So any guesses what the inverse function would be? It has to undo the job of this one. Well, undoing plus 2 is probably minus 2, right? This is the inverse function. And the way we show inverse function is like this. It's represented by f negative 1 x, and I'll talk more about that in a second. So let me just write that in there, f negative 1. We'll put f of x for our original function, f negative 1 of x for our inverse function. So, for example, if I was to throw the number 6 into this function, what gets spat out as the output? What gets spat out is 8. And what makes this one over here, what makes this as the inverse, is that if I was to plug the output into there, if I was to plug 8 into here, what would get spat out of there? 8 minus 2 is 6. You're back to where you started. You see what I mean? This second function here undoes the work of the first function. Okay, we'll do some more examples and you'll see what I mean there. Alright, so we represent it by f negative 1 x. The way you actually say that is, I think I wrote it here. No, I guess I didn't write it. Okay, the way you say that is f inverse. I mean, we're talking about inverse functions. So we say f inverse of x. That's how you say that. You don't say f negative 1 like I was saying before. I was just saying that because I hadn't introduced this idea yet. But now that I've introduced it, from now on I will say f inverse of x. Now be very careful. What a lot of people think is they see this negative 1 here and they think this must be a flippin' negative. No, this is not a flippin' negative. This is not f of x raised to the negative 1 power. Okay, that's not true. If we were going to have that, f of x raised to the negative 1 power, it would look like this. F of x to the negative 1. The negative 1 would come after the whole thing, after the whole f of x. And oftentimes they'd even put it in brackets like that, f of x to the negative 1. But we're not going to worry about that. And just be clear, this is just a different representation. It's a way to represent f inverse. Okay, so it's very common that people think it's raised to the negative 1 power. It's not. It's too bad they didn't use some other symbol, but that's what they used. Okay, and I have a little more space here. I think I'm going to fill it in after I do something else. So here's how you find an inverse function. Well, I'll quickly go through the steps and then we'll do some examples. First thing you're going to do is you're going to ensure that f is a one-to-one function. Remember we talked about one-to-one functions? Basically that means that for every member of the domain, every input value, there's only one y value, and also vice versa. For every member of the range, every y value, there's only one x value. We did that in section 1.1 if you want to review that. If it's not a one-to-one function, then the inverse is not a function. So you can't say it's an inverse function because the inverse isn't a function at all. It could be an inverse relation, but it wouldn't be a function. Anyway, this point number 1, I'll talk more about in part 2 of this lesson, because as you can see, I didn't write it up here. This is actually a 2-part lesson. So in part 2, the next day's video, I'll talk more about this, ensuring it's a one-to-one function. Okay, step 2, you're going to replace f of x with y. Step 3, I'll just go through this quickly. Step 3, you're going to change x to y and y to x. Sounds weird, doesn't it? Step 4, solve the new equation for y, and step 5, replace the y with f inverse of x. Okay, quickly, or not quickly if you don't want to, stop the video and write it down. Take as long as you want, and then start her up again and we'll do a couple examples. Welcome back. Here we go. So we're going to find the inverse function of f of x equals 3x minus 2. So the first thing we should do is ensure it's a one-to-one function. Let's leave that for next day because I haven't taught you that and I don't really want to talk about it today. It goes perfectly with what we're going to talk about next day. Okay, so the next step. You'll see that most of these steps are really easy. Like look at this first step. Or second step, I guess. Replace f of x with y. It's really as easy as it looks. Instead of writing f of x, I write y. Y equals 3x minus 2. If it already was written this way, y equals 3x minus 2, of course you wouldn't replace the y, it would already be there. Anyway, you make sure it's y equals. Second step, our third step, I suppose, change x to y and y to x. So it's just like it sounds. Change this y to x, change that x to y, and we're done that step. Next step, step 4, solve the new equation for y. In other words, isolate y. I want to get that y by itself. Okay, well, I got two problems here, the 3 and the negative 2. Let's deal with the 2 first. So I will add 2 to both sides, and that will leave me with x plus 2 on this side equals 3y. And then I'm going to divide both sides by 3. I don't know why I'm showing all these steps. You guys aren't in grade 8. And you're left with y. I'll move the y over to the side. Y equals x plus 2 all divided by 3. Okay, last step, replace the y with f inverse of x. So again, it's as easy as it sounds. You just take this y and you replace it with f inverse of x equals the same thing on this side, x plus 2 over 3. And we're done. We found the inverse. So what this is saying is, whatever number you plug into f of x here, if you were to plug the output number into here, you'd go back to the input again. Sounds kind of complicated. Can you hear my chair squeaking? It's starting to really bother me. Whenever I watch the videos, I can hear squeak, squeak. It's just my chair, okay? It's no bodily function happening here or anything. Don't want anyone starting rumors. Okay, so what we're going to do is we're going to verify that these two functions are inverse functions. So the way that a lot of people think you do this, and it's worthwhile doing, so let's do this, is they say, okay, I want to verify this. So what I'll do is I'll take any number, how about 3, and I'll figure out what f3 is of the original function. Let's figure out what f of 3 is. F of 3, I'm going to input 3 into the original function, so I get 3 times 3, right? I replace the x with 3, minus 2. So I get 3 times 3 is 9 minus 2 equals 7. If these are inverse functions of each other, that means that if I take this number here, the output of the original function, if I input that into this function, what should I get as my output here? It should undo, or it should cancel what happened here, so I should go back to where I started. I should get 3, because that was my original. So let's try it. Is it true that f inverse of 7 equals 3. Let's try. Instead of x, I input the 7. So I get 7 plus 2 is 9 over 3. It equals 3. Do you see? We ended up getting the number we started with. So at this point, some people say, yay, I've proven that these are inverse functions. But you haven't. What you've proven is that they're inverse functions for the number, the input 3. But that doesn't mean that it works for every single number. And we don't have time to go through every single number because there's a lot of numbers. So how do we do this? Well, here is how we prove that two things are inverse functions. Go back up here and I will show you. If two functions, f of x and g of x, there's our two functions, if they're inverses of each other, then f of g of x equals x and g of f of x equals x. Okay, that might take a little time to look over and totally understand. But basically what's saying is if you take the composite function f of g of x, the result should be x, and if you take the composite function g of f of x, you should also get x. And it might take a little thinking here, but it makes sense, because if you put, basically what this composite function means is you're doing both functions. So if you do the one function, g of x, and then do the other function, take that value and put into f, and if they're inverses, they should undo each other, and you should end up with the original input, which is x. Ooh, that's complicated, isn't it? So how do we show that two functions are inverses of each other? We show this right here. We find f of g of x and we find g of f of x, and we see, do they both equal x? In this case, we don't have g, we have f inverse. Okay, so here's what I do. I want to know if this function and this function are inverses. So I have to find the composite functions of both of them. So I have to find f of f inverse of x. So let's find that. What does that mean? That means I'm taking the f inverse function, which is right here, x plus 2 over 3, and I'm going to input it into wherever I see x in this function. I'm going to put it in right there. Okay, I'm going to undo that. So that means I would have 3 times, oh, there's x, so I'm going to write x plus 2 over 3 minus 2 equals, well, if I'm multiplying 3 and also dividing by 3, those are gone, so I'm left with x plus 2 minus 2, which equals x. So it worked. Have I now proven that they're inverses? Not yet, because I have to also show that f inverse of f of x also equals x. I'm going to get rid of this. So let's see if we can show that. So what does that mean? That means we need to take f of x, this amount right here, and plug that in wherever we see x in this function. So I would have x, but instead of writing x, I put 3x minus 2 plus 2 over 3, which equals 3x. Negative 2 plus 2 is just 0, so it's just 3x over 3, which equals x. It worked. So this is definitely, yes, these are inverse functions of each other. We haven't proven it. Remember before I used the number 3, and all I proved it was for the number 3. Now I've proved it for every single input number, because that's what x equals in this case. It equals any input number we want. Okay, that's powerful math, people. Let's keep going. I think we do the same thing again, and we're almost done. Find the inverse function of f of x equals 1/2 x cubed minus 4. Okay, inverse function, the way we do it is we change f of x to y. Then we change the y to x and the x to y. Now we have to isolate the y. Let's move the 4 over, so we get x plus 4 equals 1/2 y cubed. We have to move the 1/2 over. So you could think of this as dividing both sides by 1/2, or the way I like to think of this is multiply both sides by 2. So I'm multiplying all of this side by 2. Right? If I multiply this side by 2, I get 2 times 1/2, which is 1, and that's what we want. We want 1y cubed, or just y cubed. Okay, then I guess I could expand that. You don't really have to, but I will. And the last step is, what's the opposite of cubing? I want to get that y by itself, so I have to take the cube root of both sides. Do I put plus minus? No, you don't put plus minus in this case. You only do that with the even indices. If it's an odd one, you don't do that. I can talk about that some other time if you want. Y equals, I'll change sides, y equals the cube root of 2x plus 8, and then I change my y to f inverse, f inverse, f negative 1, x equals the cube root of 2x plus 8. There's our answer. Verify that these two functions are inverse functions. Okay, so we're going to do the same thing. We have to find what f, you can do it in either order you want. I can't remember which one I did first last time. I'll do f of f inverse of x first, and then after that I'll get f inverse of f of x. And what do they both have to equal? They both have to equal x. Okay, so let's try this one. F inverse of x is this amount right here. And we're going to plug that in wherever we see x in there. So we're going to plug it in right there. Okay. So we have 1/2. Then comes my x. So I'm putting cube root of 2x plus 8. And that's all cubed minus 4. Equals, okay, we have the cube root and then cubed. So what are we left with? We're just left with 2x plus 8. So we have 1/2 2x plus 8 minus 4. 1/2 times 2 is 1x. 1/2 times 8 is 4. Take away 4 equals x. That worked. Remember, you have to try them both though. What are we doing now? We're taking f of x, which is this amount, and we're plugging it into, into the x. So let's do that. So we have cube root of 2 times, there's the x, so that's where I'm going to write in the 1/2 x cubed minus 4 plus 8 equals cube root of 2 times 1/2 x cubed is 1x cubed, or just x cubed. 2 times negative 4 is negative 8 plus 8. That equals the cube root of x cubed. These cancel out. The cube root of x cubed is x. It worked. These two are definitely inverse functions of each other. You don't have to check your work like this. I mean, if you have extra time, you can check your work and make sure you always found the correct inverse function. Sometimes they'll give you two functions and say, are these inverse functions? And then you would do this. You must get x for both cases here. Okay, last one's kind of crazy question here. F of x equals negative x minus 4, and g of x equals 3/4 x plus 2. We want to find fog. Remember what that is? It's the same as f circle g, or f of g. Another way you could write this, in case you forget, is f of g of x all to the negative 1, or inverse, in other words, like that, right? It's the same thing we just did. It's composite functions. So f of g inverse of x. So what do we do first? The first thing we do is in the brackets, we have to figure out what's the composite function of f of g. So let's find that first. F of g of x. What does that mean? That means take g of x, which is this amount right here, and plug it into the x value there. Okay, let's do that. So we have negative, there's the x, so all of this 3/4 x plus 2 goes right there, and then take away 4. So it equals negative 3/4 x minus 2 minus 4, which is the same as negative 3, whoops, I forgot the x, negative 3/4 x take away 6. Okay, now what we have to do, we've done the composite function f of g. Now we have to find, so I guess I should write this again. F of g of x equals that. Now we have to find the inverse of that. How do we do that? First, always write this as just y. Y equals negative 3/4 x minus 6. Then we replace the y with x and the x with y. This is what we just learned today, right? And now we solve for y. Move the 6 over, so we have x plus 6 equals negative 3/4 y. Okay, now we got to get the y by itself. So the way I do this is, when we have a fraction like this, I think of this as, since this is divided by 4, I'm going to multiply all this by 4. And then this is times negative 3, so I'm going to divide it all by negative 3. Other way you could think about it is you're multiplying by the reciprocal. See how it's negative 3 over 4? Now it's negative 4 over negative 3, or negative 4 over 3 if you want, equals y. So that leaves us with 4, or y equals, let's move the negative up here, negative 4 x plus 6 all over 3. Then the last step would be to change that y to a inverse, but don't just put f inverse. Remember, you're going to have to put fog, f of g inverse of x equals negative 4 x plus 6 over 3. You could do mountains here if you want, but it's probably not necessary. You could even, if you wanted to do the mountains, you could have negative 4x take away 24 over 3, and you could even simplify that to negative 4 over 3x, or negative 4x over 3 take away 8, right? Anyway, this is fine. If you want to stop right there, that's fine. Alright, last one is even more complicated. Maybe I shouldn't have done this one. It's going to take a little while. I was planning on a short video, but failing again. What you have to do on this one is, you have to do the brackets first. So first of all, you have to find what f inverse is and g inverse, and then you need to take the composite function of those. Oh boy, so let's find f inverse. To get f inverse, we write, instead of f of x, I put y equals negative x minus 4, change the y to x and the x to y, and solve for y. So I'm going to add 4. And then I'm going to bring, I want the y to be positive, so why don't I move the y to this side and move these to this side, so they change sides. Or if you, the other way we can think of is divide everything by negative 1. Then I change the y to f inverse, negative x minus 4. Okay, good. Now I need to find inverse g inverse. So again, instead of gx, I put y equals 3/4 x plus 2. Change the y to x and the x to y, and isolate that y. Bring the 2 over, x minus 2 equals 3/4 y. Just like I did before, I'm thinking of this as divided by 4, so I'm going to multiply by 4. I'm thinking of this as 3 times y, so I'm going to divide by 3 equals y. And then you could change that y to g because we're talking about function g, g inverse equals, oops, sorry, my pen's falling apart here. G inverse equals 4 times x minus 2 over 3. Are we done? No, all we've done is found this inverse and this inverse. Now we have to find the composite function. So we want to take G inverse, not G, but G inverse, which is this amount right here, and we want to put it into F inverse, which is right here, wherever the x is right there. Okay, ready for that? Here we go. It equals, I'm just going to put equals here, negative, then we have our x amount, but x we're replacing with 4x minus 2 over 3, and then there's a takeaway 4 here. Okay, let's do some simplifying. So that's like negative 4, negative times 4 is negative 4. So negative 4 times x is negative 4x. Negative 4 times negative 2 is plus 8, and it's all over 3. Minus, why don't we make this, put a common denominator of 3 here. So what do we have to multiply bottom by? 3. Do the same at the top. You get 12. Now we can combine some terms. So we have negative 4x. 8 take away 12 is negative 4 all over 3. I think that's pretty good. If you wanted to, you could write negative 4, factor out the negative 4, and get x plus 1 left over there. I like that actually, over 3. Either one of these two answers is fine. And that's what the composite function f inverse circle g inverse of x. Oh my gosh, it's hard to even say that, isn't it? F inverse of g inverse of x equals negative 4 x plus 1 over 3. Wow, isn't this getting complicated? Can you believe this? Show this to your grade 8 friends and they'll think that you're a genius. You know what? You are a genius. Good for you, genius. Have a good day.
I'm still searching for whispers in between yells. I'm still swimming in harmony. I'm still dreaming of